Things like that happen. Okay, so solving a system of equations using elimination. There is, again, kind of a 4-step process. That being said, it sounds a little bit wonky just reading it out. So we're going to do those steps along with the first question here. So solve the system of equations. When you're solving a system of equations, your step 1 is you have to make sure you have the same amount of a variable. So that way your coefficients for x or y, really key, not and, or y are identical. So what that means is, like in my first equation, you could have 2 x's, and the second equation also has 2 x's. Or it could be they both have 4 y's. Both equations have 4 y's. Both equations have negative 2 y's. But they have the same coefficient in front of the same variable. Does not matter what that coefficient is, but it just has to be the same. So in this first example that we have, you can see that there are 7 y's in the first one and 7 y's in the second one. So we're good. We're set. That's what like your step 1 requirement is. If they're not the same, we'll go through an example of how to make it so they become the same, but basically you're going to multiply or divide to get them to be the same number. Whatever the number is, doesn't matter. It just has to be the same. So this is like the weird part. You can add or subtract your equations to eliminate one of the variables. So you're going to add your 2 equations together completely to cancel it out. So on this one, I'm going to put a big plus sign right here and a big plus sign here. And then I'm going to add 2x plus 3x gives me 5x. What's 7 plus negative 7? 0. So I can add my y's, which gives me, I'm going to write plus 0y just because it's our notes and it's nice to show that. And then I'm going to add the right side, 13 plus 2 gives us 15. So this is our like step 2. Our step 1 was making sure that they both had the 7s. So now my equation together, the 2 of them added together, tells me that 5x is equal to 15. Can I solve for x? Yes. So now I'm going to divide both sides by 5. So then we have that x is equal to 3. So that's our step 3 solving for it. Am I done? No. So now we need to solve for y. So I can plug that 3 into either equation initially. Does not matter which one. So I'm going to plug it, let's say, just into the first one. So it was 2x plus 7y equals 13. I would always plug it into the easier one. So then I get 6 plus 7y equals 13. And so then y is equal to 1. So I think this is really cool, and it's really like a weird property, and like, why can we do this? Why can I add and subtract equations? The only reason you can add and subtract the equations is, 1, the question tells you it's a system. That's key, so that way they're related. We know these 2 equations are related to each other. And part 2 is that they cross each other at a point, right? They have an intersection point. That's why they're a solution. So we know that at one point they match up with each other and their values are the same. So because of those 2 things, you can add them together, which I think is really weird, and it's kind of hard to understand that as well. Gil. One variable, because if both variables were the same, they both cancel out, and then you're left with nothing. As a graph. Yes. Yeah. Yeah. Okay. Let's skip the verification part. So let's try this next one. So looking at this next system here, step 1, do I have a variable that has the same coefficient? Yes, my 2's are the same. I have 2 x's in both of them. In this case, I want to subtract my equations. Why do I want to subtract this time instead of add? Good, so it goes to 0. If I was to add them, I'd end up with 4 x's, and that's not very helpful, right? You want to do what's the helpful option. So if I subtract both sides, 2x minus 2x leaves me with 0 x's. What's 6 minus 3? 3. So plus 3y. What's 6 minus 4.5? 1.5. Now I got to get rid of that 3, so I'm going to divide both sides by 3. So then y is equal to 0.5. It is good also just to like think about it. I didn't do attendance. That y is equal to half. Okay, so now we need to solve for x. You can plug x into either one. My second equation has a decimal. Much harder when there's a decimal there, right? So plug it into the first one. This decimal, I mean, like it's an easy decimal, but at the same time, still make your life a little bit easier. So 2x plus 6y equals 6. 2x plus 6, plug in my 0.5. 6 times 0.5 gives me 3. So then I get 2x equals 3, so then x is equal to 3 over 2 or 1.5. You should always give, like, if both answers are decimals, give them both as decimals, or give both answers as fractions. Be consistent with it, but that's all. Looking at this example here, our first step is making sure that our variable, we have the same coefficient on 2 variables. So that's not the case here, right? So because that's not the case, we have to make it so they are the same. Hi, Ellie. So what this says here on A, does adding or subtracting eliminate a variable here? Well, it won't, because I don't have the same coefficient. So then it says multiply the second equation by 3. Then we can add them. So what we're going to do is times this by 3. Doing that changes this equation. So 3 times 4x gives me 12x. 3 times y, sorry, negative y gives me minus 3y. 22 times 3 gives me 66. Now in both equations, I have 3 y's. So I have that same thing. So you only, because we need to make it like proportionally larger or smaller, you only do this by multiplication or division. So now my 2 equations, I'm going to just do this like in the C spot. My first equation was 2x plus 3y equals 4. My like new and improved second equation is 12x minus 3y equals 66. So like going back to the 4 steps that were on the first page, doing this is like step 1. Now I have 3 y's on both. So now they can cancel out. Do I want to add or subtract? Add, because it's a minus 3y. So when I add my 2 equations, 2x plus 12x gives me 14x's. 3y plus a negative 3y gives me 0 y's. You don't actually have to write in 0 y. I'm just doing that because it's our notes and just to make sure everyone's understanding. 66 plus 4 gives me 70. So I divide both sides by 14. X is then equal to 5. So that process there is our step 3. Last step is we actually have to solve for y. Does not matter where you plug it in. Either equation, whichever your heart desires. So let's just do the first one. So 2x plus 3y equals 4. X is equal to 5. We already figured that out. Then I subtract 10 from both sides. I wrote 6. So then I get 3y equals negative 6. So then y is equal to negative 2. What could I have changed this, like my approach, and multiplied the first equation by 2? Yes. You could actually multiply both equations. At the end of the day, it doesn't matter. You just need to have that same coefficient or the same number out front of your variable. That's the piece you need consistently. It does not matter how you get there or which ones you use, but as long as you can cancel out one of your variables. I'm not going to make you do it again for this system, but you could. That's what part D is saying. Okay, let's look at this next system. So I have 5a plus 3b equals 3, and 3a and 7b. So none of my coefficients are the same. Which one do you want to cancel out, a or b? A. Okay, so if I want to cancel out a, what's the easiest number I can get to make them the same? 15. Good. So my first equation, we're going to multiply by 3. My second equation, I'm going to multiply by 5. Doing so gives me 15 a's in both of them. So then my new equations, I'm going to write out a little bit lower just so you can see it. So 5a is going to become 15a plus 9b equals 9. And then again, I'm going to get a 15a minus 35b is equal to 405. Is that right? 81 times 5. Right? 5 times 1 is 5. 8 times 5 is 40. I can do math. Okay, cool. Thanks. Do I want to add or subtract these? Subtract. Good. If I add them, I end up with 30 a's, and that's not helpful. (15 minus 15 gives me 0. 9 minus negative 35. Good. So we're actually adding there. Be really careful of that. That's going to come up a lot. What is 9 minus 405, though? Good. 9 positives minus 405. Divide both sides by 44. So then b is equal to negative 9. You will have a calculator. I would not expect you guys to figure that one out. Am I done? No. So we need to figure out a now. We actually kind of have 4 equations, right? We have our original 2, the 2 that we multiplied and made bigger as well. You can plug this in into any of them. That being said, life is just easier when our numbers are smaller. So I would plug it into the originals just because it's easier math to do, but it doesn't actually matter. So if we go back, I can plug it into 5a plus 3b equals 3. Solving for a, so I have to leave the a there. B is negative 9. So then I get negative 27. Add 27 to both sides. So then a is equal to 6.
when you're getting an answer on questions like this, where it's like letters that aren't x and y, you can't write it as coordinates because we haven't given you context for which one to be our horizontal axis. If the equation had x's and y's, you always could write it as a coordinate pair. Personal preference at that point. We haven't done it yet, and I don't think they actually gave us space. So I'm just going to change a question. For D, what happens if it said verify? How do I verify that 6 and -9 are correct? Drew. Good. You have to plug it into both. That's the annoying part. The verify is time consuming, but let's make sure you do it. Miss Chow loves verifications. Loves verifications. I find them personally a little bit annoying and time consuming and not super helpful because often if you got a question wrong, you plug it in and you likely still are going to make a mistake. Just that seems to be like how it works. But verifications are helpful because if you did it properly, you should see if it works or it doesn't work. So let's go into our original equation. So 5a plus 3b equals 3. If I plug them in, so we said a, or you forget, a was 6. We should get the answer of 3. 5 times 6 is 30, plus -27. So 3 equals 3. That's good. It is not a full verification unless you do both equations. On your unit test, which is going to be in like 10 days, week and a half kind of thing, there'll be at least one time where you have to do a verification. So my second equation was 3a minus 7b equals 81. So 3 times 6 minus 7 times -9. -7 times -9 gives me a positive 63, which gives me 81 equals 81. You have to have that final sentence of the same number equaling each other. How do we feel about these? Is it okay? Is this confusing? Is it weird? How do you think? Does this better or worse, like harder or easier than substitution? Easier? I think it's easier too, personally. But even with the calculator, there just seems to be a lot more steps with substitution. Yeah, I totally agree. I agree. It's a lot more straightforward. Okay, I'm going to skip class example 5. It's the same thing. The only difference on class example 5, your answers are fractions. You can have fractions. Let's look at 6. So question 6, there's fractions within our equations. This is scary. So get rid of your fractions. Questions like this would be a really good level 5, 6. Right? It's stepping it up a level. We've now put fractions into your question. Specifically, we have put some fractions, like we're dividing by 3, so you cannot just like manipulate the system and convert them to decimals. We try and outsmart you. What I would do on a question like this is get rid of them. Make it friendlier. How do I get rid of the denominators 3 and 5? Looking at my first one. Cool. Fabulous. I'm going to multiply everything by 15 on this first equation. So when you do this, think of it this way. What is 15 divided by 3? 5. So then this is leaving me with 5 and the x minus 2. Minus sign, I'm going to rewrite so that way I don't forget that I'm subtracting. Now, what is 15 divided by 5? 3. So this second part is now going to become 3 times y plus 2. Two times 15, because I have to do whatever I do to one side, I have to do the other. I get 30. Let's finish with this one. Let's clean this up a little bit more before we even start worrying about elimination. So distribute our 5s in. Distribute our -3 in. So I get 5x minus 10 minus 3y minus 6 equals 30. Distributive property there. Is that okay? Can I combine anything and clean this up at all? Good, right on. So then I have 5x minus 3y minus 16 equals 30. And I would actually take it a step further and add 16 to both sides. So then I have all of my 1's together. So this is now my first equation. That was a lot of work just to clean it up and make it friendlier. A lot of room for a little error. Looking at this next one, what's the easiest way to get rid of the denominators of 5 and 2? Good, right on, multiply it by 10. This one's written slightly more differently than the first, slightly different than the first one, but it's a similar idea. So I'm going to multiply everything by 10. So when you think about this one, there's a couple ways you can think about it. I would do 10 divided by 5 first. Gives me 2. 2 times 3 gives me 6. So then that x plus 1 continues along. You could have also said 10 times 3 is 30. 30 divided by 5 is 6. The order I multiply and divide does not matter. Okay, so then let's look at the second part of that. I'm going to go 10 times 4 gives me 40. 40 divided by 5 is what? Oh, come on. 40 divided by 5, 8. So I get -8 times y minus 3. On the right side, 10 divided by 2 is 5. So I'm going to do 21 times 5, which is 105. I would say the second equation is a little bit trickier to get rid of those fractions. Do you have to get rid of the fractions? No. Everything's just way harder because when I subtract or add my two equations, like in the system, I'm then dealing with fractions, and you're just so much more likely to make a mistake. Okay, so let's continue. So I have to do distributive property, and then I'm going to combine like terms. So I get 6x plus 6 minus 8y plus 24, a negative times a negative. My 6 and 24, I can combine those like terms. So then I get 6x minus 8y plus 30 equals 105. And I'm going to subtract 30 from both sides. So now I have 6x minus 8y equals 75. All of that is like pre-solving the system. How are you guys for space? Not great. Okay, I'm not going to do the whole one, but at this point, I don't even have variables that cancel out. So if we want to cancel out, it doesn't matter which, but if we want to cancel out our y's, because they're just going to be a little bit smaller numbers, that's all. I'm going to multiply my first one by what? 8. Good, because I want 24 y's. My second one, I'm going to multiply by 3. Let's just do this step, and then I won't go through the elimination part. So this 5 times 8 would give me 40x minus 24y. 46 times 8 is 368. Again, I don't expect you guys to do that without a calculator. I mean, you can, but I don't expect it. Second one, I'm going to get 18x minus 24y equals 225. Would I add or subtract my two equations? Good, you'd subtract them because then I'm subtracting a negative, which gives us adding. That's a lot. That one was a lot. And that's what I mean, that would be a level 5-6 question, because there's a lot of like pre-math before we can do the systems math. A lot at play there. That's like the big stuff for this unit though. After this, we get into like word problems where it's you set up your equations and then solve. It's not a bad unit. Okay, so these are the practice questions I want you to do. Again, I've kind of chosen them so you guys can space your workout a little bit easier. So that way it's not so tiny, the space they give you. Like, I don't understand how they expect you to do them. On number 1, I want you to verify only one of them. The instructions say you have to verify both, so you only have to verify once. After that, don't worry about verifying again. And then that's it for the day.